algorithms, and we are also seen some problems for that particular algorithms, right? So also the difference between that first unit to third unit and fourth unit is from that first unit to third unit we have seen algorithms and we have seen problems for encryption and decryption methods. Okay, so but in our fourth unit it's only just an authentication and providing confidentiality. So what are the algorithms are used for providing confidentiality and also for providing authentication? This is the concept, this is the main core of our fourth unit, right? So from the in our previous classes, we have seen various algorithms for encryption and decryption purpose. Okay, so we had a plain text and we need to encrypt that plain text into ciphertext, and what are the methodologies or what are the techniques we have used. Okay, so we have seen that methodologies, but in our fourth unit, there is no encryption is going to take place. There's no decryption is there. It provides authentication for a full transactions. Okay, so this is importance of that fourth unit, and we have various techniques to provide authentication also. Right, so we have seen that a MAC function, hash function. Okay, so MAC function, message authentication code, hash function, and security of hash function, SHA algorithm, secure hash algorithm. These are the concepts are providing only the authentication and confidentiality for a sender and user during the transaction, sender and receiver during their transaction. Clear? Okay, so there is no encryption takes place here. There is no decryption taken place here. Okay, it just provides an authentication and confidentiality. Also integrity. Okay, so you just remember that in our MAC function also, in our hash function also, there is no alteration taken place for our plain text. Okay, so there is no conversion. There's no conversion of plain text. Okay, it just taken as an input. It just taken some plain text as an input and generated the MAC code or hash code. That MAC code and hash code is concatenated, is attached with that particular message. Okay, so there is no transaction. I mean, there is no conversion of plain text taken place here. Okay, so so what? So this is the one difference between the previous one in and our fourth unit, right? And we have seen MAC function, hash function, secure hash algorithm, right? And today we are going to see something about a digital signatures. So is there any doubt in our previous sessions? If you have, you just ask now. 2 minutes, or else we can move to our new topic. So, can I take it as you have got clear with your previous sessions? You don't have any doubts, right? Ashwin? Ashwin, are you there? No. Charumati?
Present,
Charumati?
sir.
Okay.
Sir.
Okay. Durga? Durga? No. Yeah. Who's that? Okay. So 51 is physically present here, but mentally wherever, right? So anyway. Right. So digital signature. So this is the main concept which we are going to see today, and it is an interesting one, right? So we first of all we before entering into the digital signature concept. So what is digital signature? What are the practical applications we are using as a digital signature? Clear? Okay. Simply telling, in your mail itself, if you draft some mail, some checkbox will be there at the end of that page. It's just like it's just ask the use this as a digital signature. If you click that checkbox, you can yes. If you click the checkbox, you can the tick mark will be shown there, right? So that is a digital signature. And we have another example also in our government websites. Okay, so in our government websites, if you need to register your profile in that particular website, you need a digital signature. For filing a GST, you need a digital signature. For file that income tax, you need a digital signature, right? So this is the main part of digital signature. What is the purpose of this digital signature? Is digitally they want to verify you as a legal one. Okay, so that is the main purpose of digital signature, right? So for example, one patent website is there, Indian patent website is there, IP India patent website is there. If you want to register uh, they will ask this kind of digital signature. The digital signature vendors also there. Okay, so some of the vendors are there to provide you a digital signature at some cost, right? So this digital signature is also classified into various classes: class 1, class 2, class 3, up to class 5, right? So based on the needs, the class will be varying, right? Okay, so that is a practical usage of the digital signature, right? Okay, so digital signature is an authentication mechanism that enables the creator of a message to attach a code which acts as a signature. Okay, so it is just an authentication mechanism, or like your signature in the paper, right? So in your document, you will sign. So that signature means that signature knows. So you have read that all the documents. You have read all the documents, and you acknowledge yourself as a signature. Okay. So this is a manual one. Like digital signature also, you have verified all the things. You have verified all your digital documents and send the authentication. Okay. So for that authentication purpose, we are using digital signature, right? And digital signature is a cryptographic value. It's like a cryptographic value. The validity will be also there in the digital signature. Maximum validity at least 1 year or 2 years. It's based on that cost. Okay, so the digital signature will be it has some validity 1 year or 2 year, or based on your cost or based on your needs, the validity will be high. Okay, so after once the validity finished, you need to renew your digital signature by paying some cost. Okay, so it's like a cryptographic value. So that digital signature is only belongs to you only, not to others. Okay, so it's a cryptographic value. Okay, so it will be calculated from the data on a secret key. Okay, the cryptographic value will be generated or calculated by using from the data. From the data is nothing but your plain text. Okay, and the secret key known only by the signer. Okay, so here in our hash function, and also in our MAC function, the data will be comprised, and some hash value or MAC value will be generated. Clear? Okay, in this digital signature, the MAC value, I mean, the plain text value will be there. That is, the message value will be there, and also the secret key will be known only by the signer. We can merge, or we can attach that message along with the secret key and compile that message and create some value. That is a cryptographic value, and that is nothing but a digital signature. Yes. So signature is formed by taking the hash of the message and encrypting the message. The same thing which we have seen previously in that hash function. Okay. So a hash of a message, we can take some hash value of the particular message, and encrypt the message with the create as private key. Create as private key is nothing but the secret key which was known by the signer. Signer here is nothing but creator. Okay. Signer is nothing but a creator. Clear? Okay. So signature guarantees the original content of a message. It guarantees it how to say, like your document. If you need to submit your assignment. Okay. So if you want to submit your assignment, you just write your name there, and you just write that assignment, that is questions. At the end of the page, you just signed your name now. I mean, you are just signing now. So that guarantees this document was written by me only. That is a guarantee, right? So likewise, in digital world, the digital signature guarantees the original content of a particular data. Okay, so that is a digital signatures, one of the functionalities, one of the usages. Clear? The properties of digital signature. Okay. So what are the properties? We have listed out some three properties here. Verify author, data, time of a signature. Date and time of the signature. Second one is authenticate message contents at the time of a signature. Verified by the third parties to resolve disputes. Clear? Okay. First thing is verify author, date, and time of the signature. So digital signature, we will not create that kind of digital signatures. Some of the vendors are there. Okay. So in the third point, the third parties are there now. So like that, that vendors only providing the digital signature. It will not be created by us. Okay. So that vendors also will be authorized by the government. Okay, maximum central government, that will be authorized by the central government. Clear? Okay, so it verifies that digital signature, verifies the author. Okay, so if you want to file a patent through your registered website, I mean through your IPR India, I mean online IPR India. Okay, so you as already told, you need some digital signature. Okay, so that digital signature verifies that signature is belongs to you, number one, that is author, and time and date of that particular signature. Okay? It verifies all the things. And authenticate message is nothing but that content has been already read by me, that content has been known by me. That is an authentication. Clear? Authentication message. Okay. And the third point is verified by third parties. Yes, so we will not create those kind of digital signature for that digital signature creation or for the digital signature generation. The various vendors are there. Okay, so that vendors will be authorized by the government. Okay, so they are a third parties, right? Okay. Requirements of digital signature. What are the requirements? Okay. Signature must be a bit pattern that depends on the message being signed. Okay, it's like a bit pattern. Bit pattern in the sense the size of the signature will be depends on the message. Okay, message means if you have long message, the size of the digital signature will also be long. If you have a short message, the digital signature size will be short. Clear? The signature must be some information unique to the sender. Okay, so the signature must be some information unique to the sender. It is unique to each and every sender, or it is unique to each and every user. Okay, so it will not be repeated to any other person. Okay, your signature is only for you, so there is no repetitions. It will be unique to you only. Clear? Okay. So third one, it must be relatively easy to produce that digital signature. It will be more easy, right? So we have a message and we have a secret key. Okay, so by clubbing that message and secret key, I can generate a digital signature. That's it. Okay, it will be relatively easy, and it will be relatively easy to recognize and verify the DS. Okay, so the verification also is easy, right? Comparing to various methods. Okay, next one. Be computationally infeasible. Okay, so computationally infeasible. Okay, what is meaning that with new message for existing digital. யார் இப்போ எறும்பு மருந்து எடுக்கணும்? Okay. Right. So with new message for existing digital signature, that is the computational is nothing but the process taken for a particular generation. Okay, particular generating of keys. Okay, so that is a computation, right? So computation is nothing but if you are running a program, the time taken for compiling your program, that is a computation, right? So for our digital signature, the computation is somewhat low, somewhat efficient one, right? With new message for existing digital signature, right? And with fraudulent digital signature for a given message. It will also check the existing digital signature and also expired one. Expired one in the sense, as we already told now, so the lifetime will be 1 year for that, but particular, we can take it as 1 year. Okay, so the lifetime for a digital signature is 1 year. So after 1 year, the digital signature will be expired. If you need the same one, you need to renew, right? So the computation thinks, that is, the system can easily check whether this digital signature is an existing one or expired one, right? So these are some of the requirements of DS. So this is an overall diagram for that digital signature. Here is a Bob and Alice. Bob is a sender, as already told, and Alice is a receiver, right? So now the message is there. Okay, that message will be sent to Alice. So you want to create a digital signature for that particular message. Okay, so that message along with that Bob's private key. Bob's private key is nothing but Bob's password. You can take it as a Bob's password. Okay, so you just clubbing those things, message and Bob's private key. You are doing a digital signature algorithm. We can see the digital signature algorithm in our later slides, right? So by using the digital signature generation algorithm, some signature will be generated, and that signature is concatenated with our original message. Clear? With our original message. Okay. So after all the process got over, that original message along with our signature will send to the receiver side. In that receiver side, the digital signature verification algorithm will be taken by Alice. It verifies the signature. Okay. If the signature is valid, the Alice can confirm this message was by Bob. If the signature is not valid, this is somewhat something happened because of that intruder, right? So that digital signature verification taken place by using Bob's public key. Here, there is no key from Alice side will be used. Just note down that there is no receiver's public key and also private key. Here, we are going to use sender's public key and private key. Sender's private key is used for digital signature generation algorithm, and sender's public key is used for digital signature verification algorithm. Okay, so both sides, here also Bob's and here also Bob's. Okay, so there is no keys of Alice will be used here. Clear? So this is the overall diagram of that digital signature. Okay, so this is an explanation about that. Okay, so we have two approaches in the digital signature. One is direct digital signatures and another one is arbitrate digital signature. Okay, so we have two things here. Just wait it on. Okay, so we have two things here. One is direct digital signature and another one is arbitrate digital signature. Right. So what is the direct signature model? Okay, so this is the first type. It's only including two parties, one to send message and another to receive it. According to direct digital signature, both parties trust each other and knows their public key. Okay, simple. So direct digital signature is a simple one. It is easiest one. Okay, so the main thing in the direct digital signature is only two persons are going to involve in the transaction. One is a sender and another one is a receiver. Okay, and second thing is the public keys of both the sender and receiver will be known mutually. Okay, so receiver public key and sender public key and receiver. Okay, so this is a main thing in the main important points in the direct digital signature. Okay, so those two persons, sender and receiver, are trust with one another. Okay, trust with one another. Clear? So these are the some points in the digital signature model. Okay, so this is a direct digital signature. Here is a message, and here we have generated a hash value in that message. Okay, so that hash value was encrypted by using the private key of A, private key of sender. Okay, private key is nothing but a password of a sender. So that encrypted hash value will be concatenated with that message. Okay, now the message along with that encrypted hash value has been sent to that receiver side. Here, the receiver received the message along with that encrypted hash value. Okay, so two processes there, like a hash function or like a MAC function. Here also two processes there. One is decryption of hash value taken place. Another one is the another hash function has been done in that receiver side. Okay, so after getting the hash value and after decrypting the hash value from the sender side, the both values will be compared. Okay, so this is a direct digital signature. So as we already told, both the sender and receiver will know the public key of both of them, and also they will trust each other. Clear? So this is a simple process. Okay, right. That is known as direct digital signature. And the next one is arbitrated digital signature. So arbitrated digital signature includes three parties. Okay, so one is a sender, another is a receiver, and the third one is a arbiter. Okay, so we can explain by using a diagram. Right. Okay. The message here, the three parties taken place. Okay, in the director or in the direct digital signature, only sender and receiver are there. But in the arbitrated digital signature, both the sender, receiver, and the arbiter will be taken place for the transaction of your messages. Transaction of your messages. Clear? Okay. It involves use of an arbiter. Okay. So validates any signed message. He is like a third person. He is like a third party authority which provides a digital signature. As I already told, as we already discussed, the digital signature will be provided by some other vendor. Like that, arbitrated digital signature, the arbiter will act as a authorized third party. The function of that authorized third party is validate any signed message. He just validates the message. Okay, the signing will be taken place in the sender and taken place in the sender. Okay, but it will be verified by the third party. Okay, what is the requirements? It can be require suitable level of trust. Okay, so here the sender and receiver will not trust each other. Okay, but in the direct digital signature, they both trust each other. But here, the sender and receiver, they don't have trust each other. So they appears in front of some third party, the third authorized party. The main function of the third authorized party is he just want to trust. He just want to give the trust level to the sender or receiver. Okay, okay. So if A sends a message, B just verify with the third party whether A is a genuine one or not. Okay, so that is a function of that third party. That is a function of that arbiter. Okay, it can be implemented with either private or public key algorithms. That algorithms, right? Third important one is arbiter may or may not see message. Okay, the main function of that arbiter is to verify the message, to validate the message, not to read the message. Clear? So this is the major difference. The arbiter is only for validate your message, validate your authentication, validate your presence, but not your message. Clear? So he will not. That is not sure. Okay, that is not a how to say not a mandatory one. Arbiter may or may not see the message. Okay. Here we have some three different kinds of arbitrated DS. Okay, so some three different kinds. Okay, so first one is conventional encryption. In that conventional encryption, the arbiter sees message. Okay, so we have recently told that arbiter may or may not see message. Okay, so the first type is he just sees your message. So what is the thing? So X is a sender, it sends a message. Okay, so what will be there is X sends a message to that arbiter. Okay, that is X is a sender. Okay, so A is an arbiter and Y is a receiver. Clear? Okay, so what transaction is from sender to that arbiter, sender to the third party? What the transaction contains is HM is nothing but hash value of the particular message. Okay. So ID of X is a private key of the X, private key of the public, private key of that particular sender. Sender is X here. Okay. So EKXA is nothing but the secret key which is used for encryption. E is nothing but encryption. Okay. So by using all those things, we just created a sign for a sender. We just created a sign, and that sign is concatenated with your message. Okay, so this message will be sent from the sender to the arbiter. Right now, the arbiter sees the message. The arbiter reads the message. Okay, so now, so after verify, the arbiter will send your message to the, will forward your message to the receiver. Receiver is Y. Okay, so that message contains, what are the things that message contains? Okay, so EKAY, okay, you just HM is a hash value of the message. IDX, the ID of a particular sender. EKA, the encrypted one. Okay, so this previous things, EKXA is the, so this previous message will be forwarded along with the IDX. X ஓட ஐடியை கொடுக்குறாங்க. whether already சொன்னோம் இல்லையா, whether if A send a message to B, B just want to verify A is a genuine one or not. Okay, so here the arbiter send a ID of a, ID of a sender. Okay, the arbiter will send a message to receiver about the ID of a sender. Okay, so this is IDX. It will be taken place. The whole message will be encrypted by using some key. Okay, so by using some key, that is a E of K of it. What is this T? That is a time of that particular slot. Okay, so that is a time of a particular slot. So this is a conventional encryption. Clear? Are you clear with this? Any doubt in that? Anybody?
No doubt, sir.
Okay. Okay, so this is known as first thing, conventional encryption. Arbiter sees the message. Okay, it's going to be. Okay, so your attendance has been opened at 11:45. Okay, so சொல்லியாச்சு attendance அப்போ போட்டுங்க 12 o'clock close ஆயிரும். So நம்ம கொஞ்சம் ஃபாஸ்டா முடிச்சலாம். Okay, so this is type 2, conventional encryption. Arbiter does not seize your message. Arbiter will not see your message. Okay, so what are the transactions happen between the sender to sender and arbiter and receiver? Right, so this is how to say, this is a three-way one. Sender sends a message to arbiter, arbiter verifies that message, and it sends to the, and it forwards to the receiver. Clear? Okay, so this is the second one, conventional encryption. Arbiter does not seize message. Okay, so what are the things happen here? X is a sender and A is a arbiter. Okay, so what kind of message is there? So the message has been encrypted first. Okay, so after that encryption, the hash value is created for that encrypted message. Okay, so the IDX is nothing but ID of a particular sender. Okay, so these three things has been encrypted by using the private key of A. Okay, so that encrypted value will be concatenated with that encrypted message. Just note it down. The message is encrypted always, and after encryption, the hash value is generated. That hash value encrypted. That hash value also encrypted. So both the encrypted message and encrypted hash value has been concatenated with that ID of a X, ID of a sender. Clear? Okay. So that message will be sent to the sent to a arbiter from the sender. Okay. So second thing, arbiter verifies that message. Arbiter does not see your message because that message was encrypted thrice here. Okay, here is here once and here two. Sorry, twice. Twice the message was encrypted. So it was not. It will not shown to that arbiter. Okay, so arbiter verifies or validates your transaction and he forwards that message, as I already told, to that receiver. Okay, so you just go through this PPT and you can get some idea here. Okay, so here also timer is there, message, and that message was encrypted. That encrypted message generates the hash value. It was concatenated with that IDX. The whole thing was encrypted. Okay, and it was concatenated with that encrypted message. Right. So the same thing. There is no alterations from that previous one. he just encrypt the previous one by using the IDX. The arbiter வேலை இங்க என்னன்னா உங்களோட எக்ஸோ ஐடியை ஜென்ரேட் பண்ணி ஐடியை கொடுத்து அதை என்கிரிப்ட் பண்ணி ரிசீவருக்கு சென்ட் பண்றது. This is the thing. Okay, this is the second type, and this is the last one. Public. Oh, yeah, yes. Public key encryption. Arbiter does not seize your message. This is one of the types. Okay, so here also the message is there. The message was encrypted, and the message was again encrypted with that public key. So RX is a private key. So that again it was encrypted by the public key of Y. Public key of Y is nothing but public key of receiver. Okay, that encrypted message, that encrypted whole encrypted message was concatenated with that ID. So after concatenated, it will again encrypted by using the private key of X. After encryption, it was concatenated with that ID, clear ID of a particular sender. Okay, so X sends to a message A, and A will verify the message, and he also encrypt the whole thing. He also encrypt the whole thing and forward it to that receiver. So these are the three kinds in that arbiter digital signature. Clear? Do you have any doubts in the digital signature? We have two types of digital signature. One is direct digital signature, and another one is arbiter digital signature. In the direct digital signature, only sender and receiver is there. But in the case of arbiter, we have three things. Three people are there. One is sender and receiver, and another one is third party. That is arbiter digital arbiter. Okay. So arbiter's main function is he just want to validate both the sender and receiver. Clear? So this is the main work of the arbiter. Clear? So the forward, the transaction will be the arbiter may or may not see your messages. We have three types of transactions, or we have three types in that arbiter digital signature. Okay, so first we have seen all the three types here. Okay, so if you have any doubts, you just ask me now. Okay, Akila, answer your attendance. Akila, Amruta,
Sir.
Arnold, Arnold.
Aguilar, sir.
ஓகே. ஸோ நீங்கள் வந்துட்டு ஆன் பண்ணிட்டு ஜென்ரலாக சொல்கிறேன், நீங்கள் வந்துட்டு ஆன் பண்ணிட்டு அப்படியே வச்சுட்டு போயிடுறீங்க, நாங்கள் தனியாக கத்திட்டு இருக்கோம் இல்லையா? ஸோ அட்டண்டன்ஸ் வந்து நீங்கள் பார்க்கலாம் மார்க் பண்ணிடுவீங்க இல்லையா கரெக்டான டைமுக்கு, ரைட்? டுமாரோ ஆன்வர்ட்ஸ், நான் ஜென்ரலாக சொன்னோமா, பை டுமாரோ ஆன்வர்ட்ஸ் த மேனுவல் அட்டண்டன்ஸ் வில் பி டேக்கன். உங்களுக்கு செல்ஃப் அட்டண்டன்ஸ் சொல்லியிருந்தாலும் மேனுவல் அட்டண்டன்ஸ் எந்த டைமில் வேணாலும் எடுப்பேன், ரைட்? பார்ப்போம், அந்த டைமில் அவைலபிளாக இருந்தால் மட்டும்தான் அட்டண்டன்ஸ் கிடைக்கும், ஃபார் ஷியர். Okay, so inform your friends also, right? Okay, thank you. And at 12 o'clock the attendance and quiz will be closed. Okay, so you just attend that quiz and mark your self attendance without fail. Clear? Thank you.